And welcome back. Now today we're returning a little bit to a topic that was done a couple of videos ago, all about turning off your Arduino or other microcontroller using a couple of MOSFETs. And there were a few comments about that, not specifically about what I was doing. Everybody seemed quite happy with that, but there were a few comments about, well, there are alternatives basically. In fact, if we look at the comments now, we see here, look, one from Frank Muller says, what about the TPL5110? I'm going the TP what? And further back down, YTFP saying TPL5110. I'm going, maybe I should know about this. And Dan Harold says, well, I'm not sure what the name is, but I know there's something in there, and lo and behold, I've replied, yeah, there's a TPL5110. Not that I knew anything about it at the time. But it was, I thought this has got to be worth investigating to some degree, so I did. And there's a dearth of information out there. Adafruit have a couple of breakout boards. Apart from that, though, silence. Our Chinese friends have not taken this on board. I sort of understand why, perhaps, when we get into the depths of this thing. Perhaps you will too, but I'm still surprised they haven't made some sort of module out of it. So well, in the interests of this channel, I've actually gone and bought the two Adafruit ones. One here, this is the TPL5111 and the TPL5110. Now this one here is in fact a 5110. Now you probably can barely make that out. I'm just glancing around for my pointer. Right, so this little chip in here, that is a TPL5110 that I bought from eBay. Thinking, yeah, I'll stick that on a little board and solder it up. Oof, was that tiny? So what I'm going to do is show you a bit of video that I did when I got it, just to show you how tiny it is, and then we'll return to this board here, well, the breadboard that is, with a few components, just to see exactly how it works. And it surprised me, so pay attention. So you can see that on this board there is that tiny little chip there in the middle, that one there, that's the TPL5111, which is slightly different to the next one we're going to be looking at. Now as it happens, I've got one of those little tiny chips. There it is. Now it's a surface mount device, and it's only available as a surface mount device. There it is in there. How I'm going to solder that onto this little PCB, I don't know whether I'm going to have a success or not, but I'm certainly going to give it a try. And here's a couple of pictures I took just as I was doing it. Actually, the first picture here shows that I've managed to sort of solder one leg to keep it all stable, and then I put it into my little clippy thing and soldered all the rest, and it just happened to line up nicely on this PCB, and well, that was it really. Not too difficult, because that'll convert that SMD component then into a through hole component, because you can see I can put header pins in there. What I really need though is a custom PCB if this was going to go into any sort of project, which brings us nicely onto our video sponsor this week. PCBWay, PCB prototyping the easy way. With more than a decade in the field of PCB prototype and fabrication, they are committed to meeting the needs of their customers. All new member sign-ups get a $5 welcome bonus, and your first prototype order is free. Why not try their online quote system now? So I'm going to try and solder that little tiny SMD device onto this PCB now, and well, we'll see just how far I get. Right, so I have actually managed to solder it on here, not without a little bit of difficulty, but it was okay. And well, I put it all together, and it wasn't quite behaving the way I thought it might behave, but in fact it is behaving exactly how it should behave according to the specs. Talking of which, if we have a look at the specs over here, so this is the TPL5110 we're talking about now, not the 5111. I haven't even looked at that really. I know it works slightly differently, even though I do have the Adafruit version or breakout module for that as well, but we're not talking about the 5111 at this time, just the 5110. So now the description here, as you can see, it says it's a low power timer with an integrated MOSFET driver designed for power gating in duty cycle. Yada yada. I'm sure you can read this as well as I can. Basically, it's a very low power switch in the same sort of way that we did in the last video but one, where we had a MOSFET in the main power line. So it was a P channel, mostly kept off by a 100k resistor to the plus VE positive, right? And then we turned it on with another MOSFET, or it could have been an NPN, we reckon, but I've never actually tried that. So what this is doing is to say, well, I'll turn on your device periodically, and unless you tell me that you're done, you've actually done whatever it is you need to be doing. Say you're logging the water level in a water tower, for example, right? So I switch you on, you do your business, check in the water level and maybe the humidity or temperature or something like that, and you do all your business. And when you've done all that, you go, I'm done. You can switch me back off now. Okay. So, and then the device will switch you back off until the next time it's right for you to start measuring that water temperature again, or level, or whatever it is. All right. However, there is a little catch to that, so we'll have to pay special attention to that. Now, when I put this onto my breadboard, so when I built it up and tried to measure the output, that's what this scope probe is now on, in fact. When I tried to measure that output, my multimeter was just going haywire, and I just wondered what on earth was happening. So I put it on the scope, and slowly but surely, more slowly than surely, things came clear. So what I'm going to have to do is fire this up and put it on the scope. But before I do that, I'm going to have to describe, using my little whiteboard. I'll grab that so that you know what to expect, because otherwise it'll take too long to figure out what's going on here. Okay, so right, whiteboard, a little bit of drawing, and then we're going to look at exactly what happens with this TPL5110. Right, let's assume then that you've set up your TPL5110 to have a 1 minute period, right? So every minute you want to check the level in the water tank. Now in real life, of course, it's probably going to be like once an hour or something, but we'll do once a minute just so that you can see what's happening here. Right, so what's going to happen on the output then? Now remember, this is a P channel MOSFET that needs to be driven. It's in the positives line of your power supply, so that when you switch on, it will be off for a very brief period during the initialization period, and then it will drop and switch on the MOSFET. Okay, and it will stay on. Now this is the 1 minute period here, right? This is the 1 minute. So your Arduino, or whatever it is, your microcontroller, can be doing whatever it likes in this period because it's switched on. But what the TPL5110 is expecting at some point during that minute is that, okay, I've done, you can switch me back off. Okay, so let's assume then that at about this time, the pulse is given here to say done, and the TPL5100 will then immediately say, great, I'm switching you back off. Okay, this is the MOSFET off. Okay, so that pushes it high. Now, the surprising bit for me now is, because we took an awful long time at this stage here to actually, you know, do our water measuring, temperature sensing, whatever, far longer perhaps than what we might have expected, and perhaps it was 45 seconds at this point before we said done. The period, which is still, you know, the 1 minute here, expires at that point there, doesn't it? At which point the TPL5100 says, it's time to turn you back on again. So at this point here, it gets turned back on. And you'll think, hang on a minute, if that was from here to here 45 seconds, and this bit here was 15 seconds, now it's a minute again that I've got to make another measurement. Now maybe this is what you expect, maybe it isn't. It was a bit of a surprise to me. I assumed that once we'd had the done signal, that would initiate the time period all over afresh. Not so. So what happens then in this particular case, you've had your minute, 45 seconds of doing something, 15 seconds of sleeping or being turned off or whatever. Well, you would in fact be turned off at that stage, right? Because the MOSFET would have turned off the power, and then you're back on again. Now, if this time you do things a little bit quicker, maybe there was a bit of initialization done over here that doesn't need to be done again, and you go, I'm done at this point now, so I'm done here. It goes, great, I'll switch you off. Now, if this was 15 seconds, it will then switch you off until the next minute period comes up from here, so that'll be off for 45 seconds now, and then it goes, right, now I've got to switch you back on again. And that's how it works. Now, what happens then if you don't get the done signal within that time period, that minute? You know, you've taken too long or things aren't working out the way you planned. Let me clear this down and I'll show you exactly what happens. So, what we're going to assume, there's a 1 minute, or whatever the time period is here, we'll call it 1 minute, but it's whatever you've set in this particular circuit, and you can adjust it between, I think it's 50 milliseconds and 2 hours. So initially it's off for a fraction of a second, then it'll come on and on and on and on, and you're still busy doing stuff in the Arduino. You might be measuring, you might be waiting for something to happen, but whatever, you hit that minute period and the TPL5110 says, I never received a done signal. So what I'm going to do at that point, I'm going to send a high to the MOSFET to switch the thing off, and then straight back down again and switch you on. Now this is where I have a problem with this timer. Yes, of course you might not have it set for a minute, but even if you did, you could be in the middle of writing to an SD card at that point. You could corrupt the whole thing if at this point here the TPL5110 decided to suddenly switch you off. It's just not quite what I'd expect. So I guess what you have to do with this device is to say, if I want to measure every minute, you've got to make very, very sure that you're finished your processing. The Arduino basically gives that done signal back to the TPL5110 before that minute is up. Otherwise your Arduino will effectively be switched off and back on again. Okay, in the middle of doing whatever it was doing. And one can only assume that it is in the middle of doing something, otherwise it would have given the done signal. Now in some ways you could say, well actually it's acting as a watchdog then, isn't it? Your Arduino's doing whatever it's doing down here, and it's got stuck. Either the logic in your code was not right, or it's waiting for a signal from, I don't know, a DHT22, that's the temperature and humidity sensor, and it's just not reading that properly. And it's got stuck. It's in an infinite loop because maybe the coding didn't take care of the fact that it might never get a reply, for example. So the watchdog timer effectively on the 5110 will go, well, I'm switching you off and starting again, so you can have another shot at whatever it is you were doing. Let's have a look on the scope now, and you'll see this is in action very, very clearly. Right, what you're looking at now, in that picture above me, where is it? Over there. There we are. That's the scope looking at the output, or known as the DRV, driver pin on the TPL5110. Okay, and that's what's going to be driving a MOSFET, a P-channel MOSFET that's interrupting the power supply. Now what the scope is showing, this trace down here means it's on, and when you see that pulse, that means when it switched it off, just as I showed you on that whiteboard. Because what it's expecting, of course, is that during this on period is to have a done signal, and that's what on this breadboard that little switch there emulates. So if I press that during an on period, right now, as you can see now, the off period is, well, it's whatever the remaining time is in any particular period. Now I've chosen, by using, I've just used sort of an arbitrary value. That's an 8.2k resistor, which is about 3.4 seconds, something like that. I'll show you the detail for that very briefly. It's all in the datasheet. And the Adafruit one actually uses on here, look, I haven't even got it out of the packet, that uses a tiny little resistor there. Let me get out the packet and we can see it a lot clearer, can't we? Right, here we are. So this is effectively a little bit like what I've got on my breadboard here. We've got the TPL5110 in the middle. That variable resistor here is that fixed one at the back. That three-prong device is a MOSFET, which I haven't got connected at all. I've just got my scope connected to the output of that. What have they got here? I don't know what else they've got. I don't know what that is. That's probably a resistor and another one. I can't tell. Anyway, all I've got on here now is a 100k resistor here to the done pin, just to bring it down to ground until I push that, and a capacitor across the plus and minus. There is a fair bit of writing in the datasheet about warnings about keeping tracks very short and all that. There's all stray capacitance you have to be careful of when creating this circuit board. So I guess Adafruit have listened to that and made things fairly short on here. Anyway, so as you can see, every time I press this button now, which I'm not sure if that button's the same as that one actually. I think that might be the one-time shot button on here. I'm pretty sure it is actually. So if you connect this up, there's a couple of options on the back of here. LED enable and a trim enable. Now if you don't want the trim on that variable resistor, you can cut that little bridging track in there. You can see that's a mounting pad with just joined up. Well, if you cut that, then you can put whatever resistor you want on the pins in here, on the delay pin. And ditto, must be an LED on here that you can disable as well, because otherwise it would take a huge amount of energy, wouldn't it? But I think what that means is, though, that if you connect the delay to positive, you then have to press this button to make it work as a one-time shot, like a monostable really. Press it, the period starts, stops, end of. Not quite sure where that would be applied, but I guess there must be a demand for that sort of action. Otherwise they wouldn't do it, would they? What I've got it wired up though on here, and as this is by default, is the repetitive action, which is why on this scope over here you can see it constantly resetting the device, or would be resetting the device time after time. Now if I press the old button, let's wait for a reset. There it goes. Press the button, and the rest of the time is sleepy buys, and then it comes off again and expecting another one now. So press the button. Now look how short that off time was, because that's all the time remaining in that time period. And that sort of is how it works, and I hope that was clear, because there's a couple of other caveats you should know about. The Adafruit module, as I just mentioned, on this board they have a MOSFET already built in. Now I haven't actually looked at the power ratings for this MOSFET, but if you remember the one that I put in the video, that video on screen now, we could put something like 20 amps through that. I suspect we can't put 20 amps through this. Okay, so there's a limitation, whatever this device is, how much we can put through it. We'll have a look on the Adafruit site in a minute. And also, well, because I'm using a naked bare chip here, it was a bit awkward to solder. I say, I wish I had got a custom PCB board by these people here, because it would have made it so much easier. I mean, it was touch and go whether or not this was going to be soldered in place, to be quite honest. But anyway, I did it. But to do that, they've obviously done it a lot neater here than what I've done it over there. Now the TPL5110, which we're not going to talk about today, works a bit differently to this. Not a lot differently, but just a bit differently. So we'll look at that in a future video. But I think this is the one that most people were talking about on the comments page that I showed you at the beginning of this video. Okay, so that's how that works. This is, well, it's not super expensive. Of course, if you configure postage or shipping into it as well, it suddenly becomes a little bit more expensive than I would have hoped, given that the actual chip itself is about, well, less than $1 in fact, especially if you buy more than one. If you were to buy a whole strip of 10 or something, you can get them very, very cheaply, but then you have to have all this supporting circuitry, including that MOSFET. Now the MOSFET, the P-channel MOSFET we showed you last time, there, that one there on screen now, is not expensive. So we could easily drive from here that MOSFET. In fact, that whole circuit we could be driven by this. If you want something that's periodic, does it in this sort of time period thing, so that it's all fixed. I was expecting, I must admit, that when this gave the done signal, that's when the time period will start again. But that means if instead of measuring something every minute, you might measure something every 45 seconds one shot, and then 40 seconds, and then 30 or 10. So it'd be a bit haphazard, wouldn't it? If you want it absolutely going to be measuring every minute on the dot, then of course this chip enables that beautifully. Right, let's have a very quick look at the Adafruit page then. So that's the datasheet. This will be on the video underneath in the description. You can read that. Now the Adafruit one is, here we are, TPL5110. So what they've said about this board, you can connect it up to an Arduino, a little bit of code, well, tiny bit of code really, mainly to send back the signal to this device to say, yes, I've finished with my cycle of whatever it is I'm doing. You can switch me off now. Now what else does it tell us in here? The delay pin. Now as I said, on my particular one I've got an 8.2K in there, which is about 3.4 seconds or something, and they've actually listed out here, probably from the data sheet. Now look, 8.3, I've got an 8.2, that says 4 seconds, and mine was a bit less than 4 seconds. For demo purposes, I'm not sure you'd have anything actually running every 4 seconds, but you don't know. There must be a demand for it, they wouldn't be doing it this slow, would they? Anyway, they give you a whole list of stuff, all of which you can get from the datasheet anyway. And as I say, on their board, it's a variable resistor, so it's not going to be very accurate. It is really a breakout board in the sense that it's an experimenter's board, because you can turn that variable resistor there to something that approximates the value, but it's not going to be that accurate, is it? So as long as it's, if you're happy with, say, round about every hour, and if that means every 58 minutes or 1 minute and 1 hour and 6 minutes, then that's good enough. But if you need it absolutely on the dot, then of course you'd have to replace that by cutting that track, as I say, and supplying your own delay resistor to ground. That's it. Well, I'm going to put this link as well, or a copy of this PDF plus a link, on my GitHub, so it's underneath this video, under here somewhere. Okay, and okay, that's it. Well, at least that's cleared up that well, lack of knowledge on my part. And to be quite honest, after all this, after the entire video, I'm just thinking, I like my circuit from that video better. We got 2 MOSFETs, we can turn it on and off as we want. Yeah, this does it periodically, and I guess we do need something from that other circuit of mine to switch it back on again. Or maybe this is your answer. Okay, that's it. Nice and short today. Hooray! Thanks for watching, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.